Let me show you how to write the Verilog code for SR flip-flop. So in SR flip-flop, we shall write the Verilog code by using positive edge trigger as well as negative edge trigger. So I'll write the code in Notepad++. So before that, let me create a folder. So I have created one folder in order to save my .v files. Here .v indicates Verilog. So I'm going to write in Notepad++. So let me save this first. Save as in desktop flip-flop Verilog codes, and my Verilog code name is SR flip-flop underscore positive edge trigger .v. Here this is the extension that you need to use for Verilog code. For source codes it should be .v. Same thing is applicable for test benches also. Done. So let me write the Verilog code for SR flip-flop using positive edge trigger. So any Verilog code starts with module. So module, next comes module name. So my module name is SR flip-flop underscore pos edge underscore trigger. So this is the name that I'm going to use. Module name. Next comes port list. So port list for SR flip-flop, what are the inputs and what are the outputs that we need to indicate here? So here output is Q, inputs are S, R, and clock. And every statement should be end with semicolon. So module name, port list. Here Q is output, S and R are inputs, and clock is input. So next comes port declaration. So here 2 forward slashes indicates comment. So I have to use port declarations. So here output is Q. Next comes input. Inputs are S, R, and clock. These are inputs. So I'm going to write this particular Verilog code by using behavioral modeling. Actually, there are 4 styles of modeling. First one is gate level modeling. Next one is data flow. Third one is behavioral, and fourth one is switch level. So here behavioral modeling is the high level of modeling. So I'm going to use this particular style of modeling here. So in behavioral modeling, there's a keyword called as always. We need to use this particular keyword called as always at the rate positive edge of the clock. Means I'm going for the clock which is of type positive edge trigger. Positive edge trigger is nothing but going from 0 to 1. So whenever the clock is changing from 0 to 1, there will be an effect on the output depending upon inputs. So always at the rate positive edge clock. Next, I'm going to write this particular thing by using case statement. So case. Next, these are the concatenation. This flower brackets indicates concatenate. Means in order to group 2 or 3 variables, we'll make use of this particular concatenation operator. So case, here inputs for SR flip-flop are S and R. So I'm going to concatenate S followed by R. So here this is the order in which we need to write. So case, concatenation of S and R. So as we know that if 2 variables are there, there will be 4 combinations. That is 0, 0, 0, 1, 1, 0, and 1, 1. We need to declare those particular combinations like this: 2 tick binary 0, 0. So here 2 stands for the size. Here I'm going for 0, 0. So here if you observe 2 bits are there. So this 2 indicates the number of bits, and here B indicates binary. So 2 tick binary 0, 0. For this particular combination, simply follow the truth table. For 0, 0, output will be Q only. So Q, here if you observe this less than or equal to symbol is nothing but non-blocking assignment. We call this as procedural statements. And here this less than or equal to is called as non-blocking statement or non-blocking assignment. So for 2 tick binary 0, 0, Q will be equal to Q only. Next for 2 tick binary 0, 1, here output will be 0. So Q less than or equal to 0. You can give directly as 0, or else you can follow the format like this: 1 tick B 0. Both are correct. Next 2 tick binary after 0, 0, 0, 1, 1, 0 colon output Q less than or equal to, actually you should not call this one as less than or equal to, it is called as non-blocking assignment. This is 1 tick B1. So simply I'm writing the truth table. For 0, 0 output is Q, for 0, 1 it will be 0, for 1, 0 it will be 1, and for 1, 1, 2 tick binary 1, 1 output. Here output is nothing but invalid. So it should be given like this: Q less than or equal to 1 tick binary Z. Here the Z indicates high impedance. The Z indicates high impedance state, means simply you can call it as floating state. Floating is nothing but either they are in on state or off state. We are not bothered about it. So simply we need to give us Z, which indicates high impedance. So whenever there is a case, it should be end with end case. And whenever there is a module, there should be end module. So this is how we need to write the Verilog code for SR flip-flop using positive edge trigger. So module, next is module name, and this is port list. And next we need to go for port declaration, means among this Q, S, R and clock, what are the inputs and what are the outputs we need to mention. And I'm following a style here called as behavioral modeling, which is nothing but we need to make use of a statement or a keyword called as always. So always at the rate positive edge of the clock. So whenever there is a positive edge of the clock, this particular block of statements get executed, means this particular case statements get executed whenever there is a positive edge clock. So case concatenation of S and R. So for 0, 0, output is Q. For 0, 1, output is 0. For 1, 0, output is 1. For 1, 1, it is Z, which is nothing but high impedance state. And one important point that you need to remember here is, in behavioral modeling, always output should be declared as registers. So here Q is the output. So we have declared output as Q. Apart from this, we need to add one more keyword called as register, REG. This is one important rule that we need to follow in behavioral style of modeling. Output should be declared as registers. And initially I'm assigning some value to the Q. That is 1 tick B 0. Why I am assigning initial value is, if you observe here, for 0, 0, it is nothing but Q, which is nothing but memory. Memory is nothing but previous state. So previously, if you are not declaring any particular value here, you will get output as don't care. So in order to overcome that problem, I am giving initially some value is present at Q, which is nothing but 0. And here register is because for behavioral modeling, output should be declared as register. You need to remember this particular point. So this is the Verilog code for SR flip-flop using positive edge trigger.